Hello everyone, welcome back to our class on math recording. We shall be looking at more questions on areas and perimeters of plane shapes. Now let's start with UTME 1991 question 44. So we have the question, as you can see from the diagram, and we are required to find the area of triangle UVW. So we want to find the area of triangle UVW from here. So let's shade it. So that's the area we want to find. And here we have the instruction. We have a square PQRS, each of side 8 centimeter. What is the area of triangle UVW? So PQRS is a square. The side is 8 centimeter, and we are required to find the area of the part we have just shaded now. So if we have that situation, then here is 4 centimeters, so that the whole length can just be 8 centimeters. So we have 8. So this is supposed to be 8 total. So definitely here we have 6. Also here we are supposed to have a total of 8. So this is 6. So obviously this part is 2 centimeters. Now let's find the area of the entire shape. Area of the entire shape. So that's the square PQRS. The square is of side 8 by 8, so that's 8 times 8. That's 64 cm squared. Now let us find the area of this part. This is a right triangle, a right angle triangle. So area of triangle UQV is half base times height, or we say base times height divided by 2. Now, since the triangle is a right angle triangle, neither the base nor the height is on the hypotenuse. So we don't need the hypotenuse. So here we have 4 times 6 divided by 2. That's 12 cm squared. We still have another triangle there. Triangle VRW is also a right angle triangle. So we have no business with the hypotenuse. We have no business with VW. So you have triangle VRW or WVR. Let's say WVR. Triangle WVR is also base times height over 2. And base times height. That's 2 and 2 divided by 2. Two cancels 2. That's 2 cm squared. Okay, so I've been able to find this part. This. We are going to find the total shape. So let's find the area of this other part. So that other part, let's try to have a sketch of it. Looks like what shape? So that obviously looks like a trapezium. So here will be A. This will be B. Distance between the A to B is the height. So this is A, B, and this is height. So area of trapezium is half into A plus B multiplies the height. That's half. A is 4, B is 6, height is 8. So 6 plus 4, that's 10 times 8, 80 over 2. That's 40 cm squared. So we found area here to be 40 cm squared. The triangle, that's 12 cm squared. The other triangle, 2 cm squared. Now area of shaded part now be quite easy now. Area of shaded part. Area of shaded, which is triangle UVW as the case may be, as required, equals to the total area of the shape is 64 minus all other areas, so minus 40 minus 12 minus 2. So once we can have the total area of the entire shape minus the area of this trapezium minus the area of this triangle minus the area of this other triangle to give us the area of the shaded triangle required. So that will be 64 minus 54. That's 10 cm squared. Or one can just say add up these areas and subtract it from the entire area. So that's 10 cm squared. Let's see what we have there. That's option D. So let's proceed. We have another one from JAM 1998, question 27. It says the diagram of PQST is a parallelogram. Obviously, PQST parallelogram. So QRS is definitely a triangle. Okay, TSR is a straight line. Okay. If the area of triangle QRS is 20 cm squared, so we use this known value. We start from there. We use known value to get unknown values. So area of triangle QRS is 20. So let's start with that. Area of triangle QRS. So we have area of this triangle to be 20. So area of that triangle there is half base times height. That's from 1990. So we are given that SR is 8 cm as part of the question. So area of the triangle is half base times height, and the area of that triangle QSR has been given to be 20. So the area here we have 20. So 20 equals to half times the base is S to R. That's 8. Then the height is unknown. So let's call the height from here to here. Let's call it H. So obviously the height from here to here transforms to a height from here to here. So this is obviously H2. Okay. Now we have 8h divided by 2 equals to 20. Let's cross multiply. 8h equals to 2 times 20. That's 40. 8h equals to 40. So obviously the height is 5. So height equals to 5 centimeters. So height here is 5 centimeters. So the height at this point transform to the height at this point, which is 5 centimeters. Now let's check what we are required to find. We are required to find the area of trapezium PQRT. Area of trapezium PQRT. Look at the trapezium PQRT. So that means the entire shape is a trapezium. But we know that PQST is a parallelogram. So let's find the area of this parallelogram. Area of parallelogram is simply base times height. And as part of the question, we are given that ST is 10 centimeters. From S to T, 10 centimeters. So area of parallelogram is base times height. So we have the base of that parallelogram to be 10. Then the height is 5, and that's 50 cm squared. Now area of the entire shape PQRT, trapezium plus triangle, PQRT labeled as trapezium in the question will be the area of this triangle given as 20 plus the area of parallelogram. So that's area of triangle plus area of parallelogram. So required area of area of parallelogram 50 plus area of triangle, which was originally given to be 20, all in centimeters squared, and that will be equal to 70 cm squared. Option C. So let's proceed. Let's move to JAMB 2002 question 32. 2002 question 32. We have a diagram. This diagram is a circle, concentric circle with they have the same center, and here we have this part to be shaded. Now we can establish a formula that area of the shaded part, area of shaded plus area of small circle area of shaded plus area of small circle equals the area of the entire big circle. Okay, now let's go to the instruction. In the diagram above are two concentric circles, as I have said, circle with the same center of radii r and r. Okay, so that means radius of small circle is small r, radius of the entire big circle is big R. If r equals to 2 over 5 of big R, so this is very important relationship. Express the area of the shaded portion in terms of pi and r. So we actually want to find the area of the shaded portion. Here are the options. We want to find the area of the shaded portion, but we only want to see pi and big R in the answer. So we want to find area of shaded. Area of shaded is what I want to find. I want to see the answer in terms of pi and r. So these are the only two parameters that should appear in our final answer. But there's also a very important relationship given. We're also given that small r equals to 2 big R over 5. Let's write it again. Small r equals to 2 big R over 5. So let's start with finding area of big circle. Area of big circle is obviously pi r squared. Since the big circle have a radius of big R. So area of small circle will be obviously pi r squared also, but this time around small r squared. So area of small circle is obviously pi r squared, but this time around small r. Now, but the examiner wants us to find the answer in terms of pi and big R. So let's work on area of small circle. So area of small circle, as we have said, is pi r squared, but because we want the answer to be in terms of big R, so let's substitute for small r there. So we have pi. Instead of small r, I write 2 big R over 5 as given in the relationship in the question. So you have that square, pi r square. So you have pi, 2 square is 4, r you square it, 5 you square it, that's 25. This will actually give 4 pi big R squared over 25. I will say 4 over 25 by big R squared. Now area of shaded. From the formula we have established, area of shaded will be area for the big circle. Look at it here, area for the big circle. On transferring this to the right minus area of small circle. We'll use that to get area of shaded minus area of small circle. And that of small circle has just been obtained to be 4 pi r squared over 25. 4 pi big R squared divided by 25. You can just work out the LCM if you like. LCM is 25. Pi R squared is equal to writing pi R squared over 1. So 25 divided by 1 is 25. 25 times pi R squared, that's 25 pi R squared. Minus, that's the minus at the middle there. 25 divided by 25, 1. 1 times 4 pi R squared, that's 4 pi R squared. So 25 pi R squared minus 4 pi R squared is obviously 21 pi R squared, all divided by 25. So 21 pi R squared divided by 25. 21 pi R squared divided by 25. Option C is divided by 23. So the correct answer is option A. Okay, let's take this question. JAM exam 2003 question 26. JAM exam 2003 question 26. A trapezium has two parallel sides of length 5 cm and 9 cm. If the area is 21 cm square, find the distance between the parallel sides. We have the choices 3, 4, 6 and 7. Definitely a trapezium has two parallel sides. The lengths of the parallel sides are basically A and B. So this is A, this is B. The area, capital letter A, 21 cm squared. Find the distance between the parallel sides. The distance between the parallel sides is the height. The distance between the parallel sides is the height. So that's what we're looking for. Let's remember that area of trapezium is 1 over 2 the sum of parallel sides A plus B times the height. So the area of trapezium is 21. So instead of area, you write 21 equals to 1 over 2 into first parallel side A is 5, second parallel side is 9. The height is the distance between the parallel side H, and this is what we are required to find. So 9 plus 5, that's 14. So we have 14H over 2 equals to 21. 2 here 1, 2 in 14, 7. So we have 7H equals to 21. Now we have 7 here 1, 7 in 21 is 3. 1 times 8 is H. So height is 3 centimeters. 3 centimeters. Let's check. So the right choice here is option A. Thank you very much. I'll see you in my next lesson.